Alright people, what's up? Sorry for this weird delay, trying to figure out this new whiteboard setting, and yeah, I think it is okay. थोड़ा बहुत blurred आ रहा है, that's because of the resolution of this board, but let's try to work with it as best as we can. कोशिश करते हैं, जैसा भी है चलाते हैं आज. So people, this is yet another class of the chapter of alcohols, phenols and ethers. If I'm audible and visible, please write yo in the chat box. Although I might not be very beautifully visible, but I think something is better than nothing right now. It'll take time for us to get used to this thing. Anyway, whatever the case may be. So the thing that we are going to discuss today is the preparation and reactions of phenols. Yes, ठीक है. तो phenols discuss करेंगे आज अपन. This is one of the first things that we need to discuss for phenols, and that is how to prepare phenols. Okay. तो phenol क्या होता है दोस्तों? Phenol is essentially this benzene ring, okay, with an OH group. Yes, that's what it is. Now this particular phenol can be generated in multiple ways, and one of the ways is right here on the screen. So what we have is benzene diazonium chloride. Okay, I know the screen is a little blurred, need to figure things out. The resolution of the screen is not very nice right now, can't really change it, but anyway, so benzene diazonium chloride liya अपन ने. Essentially we take a species that looks like this. Okay, there is an N2 positive, Cl negative over here. Now if you remember in the alkyl halides chapter, when we were trying to create halides that were phenyl halides, yes, तो अपन ने यही चीज यूज की थी. Do you remember? This is what we had used over there, phenyl halides में. So what happens is that the nitrogen over here can leave very easily. Okay, nitrogen can leave very easily. So what happens is that over here we are putting water. If we put, let's say, a chloride ion, that would get attached over here. So now what's happening is you are attaching a water molecule, essentially, that goes over here. You can lose a proton over here later, and finally what you get is a phenol. ठीक है जी? Got it? Amar, yeah, well man, if this doesn't work, then we'll go into the old setup once again. Don't worry, we'll figure things out step by step. हो जाएगा. ठीक है जी? So this is about the hydrolysis of the benzene diazonium salt, right? You take the diazonium salt and you hydrolyze it. Now some of you must be asking, sir, how do we synthesize the diazonium salt? I'll tell you about that as well. Diazonium salt कैसे create करते हैं? You essentially have aniline, ठीक है? You can start simply with an aniline, right? cool, and you reacted with NaNO2 and HCl at 0 to 5 degrees Celsius in ice bath. Okay, it's done in an ice bath, this reaction, and you are taking NaNO2 plus HCl as your reagent. So this converts this entire species into the diazonium salt. ठीक है जी, बात बनती है, cool. So some people are saying this is good, some people are saying the other one is good. Yeah, well. Gyan is asking, sir, is ethers over? Yes, Gyan, ethers is absolutely done. Ethers अपन कर चुके हैं. Cool, awesome. So let me try and change the brightness of the screen. अरे यार, शायद इससे थोड़ी visibility better हो. Just hoping. Yeah, maybe this is a little better. Anyway, so my dear friends, this is what we had. Phenol create kar liya. Now there are other ways as well. The next way that we need to see is by distillation of sodium salt of salicylic acid with soda lime. So what is salicylic acid? This is the sodium salt of salicylic acid. So what is salicylic acid? Essentially it is just a benzene ring, ठीक है, जहां पे one of the groups is OH and the other is COOH. Right? Now this, if I react it with sodium, it will become COONA. Fine. What we are doing is we are doing decarboxylation of the salicylic acid. How do we generally do decarboxylation? If you remember decarboxylation reactions from some other chapter, maybe if you've read it already or not, what you do is you react it with soda lime. What is soda lime? Soda lime, soda क्या होगा? NaOH. Lime क्या होगा? Calcium oxide. This is a very good decarboxylating agent. Okay, इससे क्या होता है? Decarboxylation होता है. So what will happen over here? This particular species will go away from the reaction mixture. It will go away from the substrate. Okay, so when you take away the carboxylic acid part, you decarboxylate it. All right, and soda lime helps us do that. So once you take away this, you will get OH at the side. Isn't that obvious? Yeah. So अपने पास क्या बन जाता है? You decarboxylate it. First you get the sodium phenate. Of course, sodium positive है तो phenol का भी sodium positive ही बनेगा. You will get the phenoxide ion, and then you can put it in water to get your final phenol. Okay. So my dear friends, please write it down. I'll just move a little bit towards the side. So yeah, Balaji is saying weird board is back to business. Absolutely. कुछ नहीं कर सकते इसका. चलो, anyway, so this was one other way of preparation of phenols. Now my dear friends, the next way is by starting from benzene sulfonic acids. Okay, so do you remember this preparation of sulfonic acid? Sulfonation process याद है आपको? Do you remember the process of sulfonation? I am pretty sure you remember the process of sulfonation. Yeah, electrophilic aromatic substitution. This is something that we have done in the chapter of hydrocarbons, which you should have done in 11th class. If you forgot about that, then we have a specific class on the revision of hydrocarbons on this channel, so you can watch that. Okay, so sulfonation, which is electrophilic aromatic substitution, you get your benzene sulfonic acid by reacting benzene with oleum. This is oleum. ठीक है, H2SO4 and SO3. So now my dear friends, this benzene sulfonic acid, I'll draw a bigger image of it in case it is not that visible. ठीक है, इसको जब अपन डालेंगे NaOH में, when we put it in NaOH, my dear friends, there is a series of reactions that happens. Okay, first of all, do you realize that this is an acid and this is a base? Do you realize there is an acid base reaction possibility that can happen over here? First that will happen, then some rearrangement will happen. Eventually we will get a phenol, and what's the procedure of that? Let us look at it. ये देखो, ठीक है, this is what we will get. So what is happening over here? क्या चल रहा है यहाँ पे? First we got the acid base reaction as we had expected. Yeah, मैं फटाफट से यहाँ पे भी बना देता हूँ. I'll make it over here as well very quickly so that everyone is able to see and understand. Yeah, increase the video quality in YouTube if this is not very visible. Try to make it as visible as possible though. Amar is saying ये board गिरेगा पक्का. I hope it doesn't fall off, man. Yeah. So PHSO3H. Now when I combine this with NaOH, first thing that's going to happen is this will get formed, PHSO3Na, right? Now when I melt it, okay, इसको पूरा melt कर देने का, fused, fusion बोले तो melt it all. Once you melt it, my dear friends, what happens is there's a certain rearrangement that happens over here. The mechanism of which is not very important. You get your phenoxide ion, and once you put your H2O in it, you will get your phenol. As simple as that. Got it? So what are the three methods of preparation of phenol? One is by the hydrolysis of the diazonium salt, the other is the decarboxylation of salicylic acid, and the third one, that is right here, is by putting benzene sulfonic acid in the presence of sodium and heating it up so that it forms your phenol. Got it? Chamak gaya? Very simple procedure. Please make sure you write this down as well. Got it? बढ़िया, कोई खास मुश्किल नहीं है इसमें. चलो. So now comes the time when we will discuss the reactions of phenols. Okay? अब थोड़ा ज़्यादा मज़ा आएगा because we are going to discuss the reactions of phenols. Okay? तो अब इसमें क्या है? There are multiple reactions. A lot of them you've seen already. Why? Because phenol, technically speaking, is just a benzene derivative, isn't it? Is just a benzene derivative. एक benzene ring है, there is an OH group next to it, so it undergoes all the typical reactions that a benzene can undergo. Yeah, you could do loads of reactions with this which belong to the electrophilic aromatic substitution nature, because phenol for electrophilic aromatic substitution is an activating ortho para directing group. Do you remember this? We've discussed about this earlier in alkyl halides chapter as well, in the revision of hydrocarbons as well. Okay? So this is an activating and ortho para directing group, and electrophilic aromatic substitution could be of different kinds. What kinds could be there? You could have alkylation, you could have acylation. Yeah, Friedel-Crafts alkylation and acylation are possible. You could have halogenation. You could have sulfonation, you could have nitration. Yeah, all the different possibilities exist for phenol as well. The only thing is its rate is much higher for the electrophilic aromatic substitution compared to benzene because of the presence of this activating and ortho para directing group. ठीक है, बढ़िया. So now apart from electrophilic aromatic substitution, we will see some examples of that as well in this class in due time. But there are some more reactions that we need to understand. What are those reactions? Again, very simply, consider the nature of the phenol. देखो, phenol क्या है भैया? What is this particular species? Do you realize it is an enol? Yeah, there is essentially a benzene component to it and an alcohol component to it. So it can show me reactions that an alcohol shows. Yes. Alcohol के reaction show कर सकता है. So one very simple reaction is phenol acting as an acid to react with a base. So it can turn into O negative plus H positive. If you put a good enough base, this reaction can happen. If you try to react phenol with Grignard reagents, you will get an alkane because Grignard will capture the H positive. Yeah, चलो ये बात सही है, बढ़िया. One more kind of reaction, people, that alcohols undergo, something that you've studied already in the 10th class as well, is the esterification reaction. ये तो याद होगा. Do you remember the esterification reaction? Yes. So esterification can also happen with phenols, and that is what we will understand right now. Formation of esters, also known as O-acylation. ठीक है, इसको O-acylation भी कहा जाता है. Got it? It is also known as O-acylation because you are putting an acyl group on the oxygen. Yes, so over here there are multiple ways of forming esters. One of them is the very simple Fischer-Spear esterification. Do you remember the mechanism of esterification from the previous few classes? Yes, abhi kiya apan ne is chapter mein usko. So it's a very important reaction. Yeah. And over here the same thing is happening. You are using an H positive. Acid catalysis to make this esterification possible. Fine. So without going into the reaction mechanism very deeply, can you tell me what will be the product? You know what happens eventually. The alcohol's oxygen attacks. This oxygen will take electrons, give back electrons, and OH will leave. Yeah. बड़ा बड़ा बनाना है तो मैं बता देता हूँ. I'll draw it if you want me to draw a bigger picture of it. Yeah. If you remember Fischer-Spear esterification, essentially what happens is that this oxygen attacks over here, oxygen gets the electrons, oxygen leaves the electrons, and this OH is what leaves. Yeah. So finally, what will be the product that I'm getting in this case? It will be a very beautiful ester that comes out of the phenol. ठीक है, तो यहाँ पे this is what will happen. ठीक है. Now my dear friends, this particular segment that we have is known as the acyl group. Acylation. ठीक है. You know the word acyl chlorides, yes? So this is acylation of the phenol. O-acylation, because the acylation is happening on the oxygen part. Technically just an esterification reaction. See, the esterification, we just give it a different name. Cool. Awesome. तो चलो, formation of ester भी हो गया. This is what is given over here. It just tells you the entire reaction. Then, my dear friends, there are other ways of creating this as well. One more way of creating the ester, one more way of doing O-acylation is by reacting. Okay. Is by reacting a phenol, okay, with an acyl chloride. Right? Why acyl chlorides? Because these are more reactive. Yes. Acids are not as reactive as acyl chlorides, so better take acyl chlorides to do the reaction. So we are catalyzing this reaction with the presence of an OH negative. Okay, what will OH negative do? It will capture the hydrogen away. What will you get? You will get your phenoxide ion essentially. Yeah, phenol plus NaOH will give you the phenoxide ion. So you will get pH O negative, which will be stabilized by Na positive. Now, this O negative can come and attack over here. Typical reaction of acid derivatives. Oxygen captures the electrons, gives back the electrons, and the leaving group leaves. So chlorine will leave away from here. Okay? Chlorine takes away the electrons from that bond. So finally, my dear friends, what will be our product? The product that we will get once again is the ester. Got it? As simple as that. So esterification of phenols gives you very important structures. You must have studied about the structure of aspirin. If you haven't, we will do it in the next class, which is on आज क्या है भैया? आज Wednesday है ना? So yeah, on Friday we are going to have the next class of alcohols. This class is not over, by the way. That will be the last class of alcohols chapter. So in that we will do two very important reactions, that are Kolbe synthesis and Riemer-Tiemann reaction. And in Kolbe synthesis we will generate a specific compound which will help us create aspirin later. ठीक है? So बहुत ही ज़रूरी चीज़ है वो भी. We will get into that in the upcoming class. But आज के लिए understand that esterification of phenols is possible. ठीक है? And esterification will be used to create aspirin later. Awesome. तो ये हो गया. This is what we have done. ठीक है? दो तरह की acylation देख लिया अपन ने. Now the third type of acylation that we need to focus on is by reacting it with some other acid derivative. ठीक है? So same thing is happening over here. Over here we are using the anhydride now. ठीक है? Nothing complicated about it. We are using the anhydride. We could have used the acid directly. Not a very good reaction because derivatives are more reactive, especially the chloride and anhydride derivatives are more reactive than the acids themselves. Yeah, I have told you this when I was telling you about LiAlH4 and NaBH4. Remember that? LiAlH4 और NaBH4 के बारे में बताते हुए I had told you this particular idea. Got it? Fine. Awesome. So, please remember, phenol can form esters. So, what this reminds me of right now, okay, इससे मेरे को याद आया that in the previous class, okay, I had told you guys to search for something, and that was the exception of LiAlH4 with cinnamaldehyde. Remember, ये मैंने आपको एक टास्क दिया था that you have to figure out if you have cinnamaldehyde एक सेकेंड दोस्तों, hold on people, this whiteboard confuses me a lot. ठीक है, if we have cinnamaldehyde and if I react it with LiAlH4, see, generally what happens is that LiAlH4 does not touch double bonds. Yes, but in the case of cinnamaldehyde, what happens is that LiAlH4, this H positive, the H negative that LiAlH4 gives me, can actually attack this particular double bond. ये डबल बॉन्ड को भी रिड्यूस कर देगा. ओके, इट्स गोना रिड्यूस द डबल बॉन्ड एज वेल. दैट्स एन एक्सेप्शन फॉर स्पेसिफिकली cinnamaldehyde. This is a homework question that I had given you in the previous class. So you should remember this exception because questions on this can be asked directly in all of the examinations. NEET हो गया, JEE हो गया, whatever examination. So you remember that cinnamaldehyde reacts with LiAlH4. Okay, ठीक है. Cinnamaldehyde reacts with LiAlH4. So what can happen in the first case is that the double bond will get reduced, and then if you put more LiAlH4, this can get converted into an alcohol itself. So remember, with cinnamaldehyde, double bond gets reduced with the help of LiAlH4. चलो, ये भी हो गया दोस्तों. So now let's just quickly do a simple question. बड़ा ही सिंपल सा क्वेश्चन है. यू हैव फिनॉल विद बेंजाइल क्लोराइड एंड benzoyl chloride and you have NaOH. What will happen in this particular case? क्या होगा इस केस में? Esterification will happen. You will get a very beautiful ester that looks something like this. PHO double bond O, again a PH. Yes, very simple esterification reaction. A specific example of that is taken over here. ठीक है? Got it? Ishan, what happens with the black background is that all of my house becomes visible. This screen is very reflective in nature, and because of that reflection, the entire house becomes visible. तो फिर मज़ा नहीं आता उसमें भी. ठीक है? बढ़िया. I'm not sure how visible all of the setup is. कुछ थोड़ा बहुत दिख सा रहा है. It's not a very. Just let me try to fix the focus a little bit more. Yeah, maybe slightly better. Maybe slightly better. चलो ठीक है. I will also take time to get used to this setup. कुछ तो अजीब सा है इसमें. Anyway, right. So now let's see some more reactions of phenols. And phenol as a starting point can be used to generate benzene as well. ठीक है, phenol को as a starting point use करके you can also generate benzene. So for that, of course, you have to do reduction. You have to do reduction, yeah. If you reduce phenol, you will get benzene. So one of the ways to do it, okay, one of the ways to do it is by using zinc dust. Okay, if you use zinc dust, this acts as a reducing agent and it converts a phenol into a benzene. Very simple. ठीक है, phenol को benzene में convert करना है, zinc dust डाल दो, nothing more. Great, very nice. More reduction reactions. One more reduction reaction is this, hydrogenation. Now hydrogenation of phenol, okay, hydrogenation of phenol is kind of rare. Okay, why is it rare? Because to do the hydrogenation of phenol, it is very difficult. It is tough to do the hydrogenation of phenols. Okay, अब tough क्यों है? Because phenol is an aromatic species. So to hydrogenate an aromatic species is it's not very easy. You need to put a lot of temperature, 175 degrees Celsius. You also need to put a lot of pressure, that is 15 atmospheres of pressure. ठीक है, आपको 15 एटमॉस्फेयर प्रेशर डालना पड़ेगा in order to reduce the phenol using hydrogenation, H2 in nickel, you know. So what will get formed at the end? You will essentially get cyclohexanol. ठीक है, so benzene is hydrogenated at such high temperatures and pressures to cyclohexanol. Very simple reaction. Once again, has to be done at very high temperatures. Normal hydrogenation doesn't work for phenol. ठीक है, phenol वैसे ही खुद बहुत stable है. Normal hydrogenation doesn't work for phenol. Cool. Now there are oxidation processes of phenols as well, and the oxidation reaction actually gives you very interesting product. Okay, the product for the oxidation reaction is very interesting. Let me show that to you. Look at this. Do you see the structure? क्या ये structure दिख रहा है? So my dear friends, this particular structure, I'll draw it again in a bigger form factor for you guys so that it's visible to everyone. Really doubtful about the visibility of today's class. ठीक है? This is what gets formed if you oxidize phenol by using either KMnO4 or K2Cr2O7 or concentrated HNO3. All of these three are very good oxidizing agents. KMnO4, K2Cr2O7, concentrated HNO3. ठीक है? So this thing that we form over here is known as quinone. ठीक है? Quinone gets formed. You essentially attach one more oxygen to this entire structure. Now the thing is, these are strong oxidizing agents. That's why you are able to convert it into a species that is not aromatic anymore. दिख रहा है ना? Aromaticity of the phenol is lost. It's possible because you are using such strong oxidizing agents. ठीक है? बढ़िया. I can see a lot of compliments as well in the chat box. So thank you so much for supporting me, even though the class is a little shabby today. I'll try to fix it the best I can. Otherwise, we'll move to the old setup. So एक दो दिन मेरे साथ just try to adjust. We'll figure it out sooner or later. हो जाता है यार लाइफ में कभी ना कभी कुछ ना कुछ. चलो ये हो गया. Okay. So now the next reaction of alcohol of this phenol is nitrosation, addition of the N double bond O group. How do you nitrosate it? You are taking HONO. Okay, ठीक है, HONO लिया, H positive लिया. A very simple reaction that's happening over here. ठीक है, you get nitrosophenol. Very simple, see, nothing too complicated about it. Let me try to explain how this has happened. Okay, right now it looks a little too much over here. If you see, काफी सारी चीजें दिख गई यहाँ पे. Let me try to explain to you how this particular reaction happens. It's a very obvious procedure in fact. So what you are doing is, again, you technically take NaNO2 plus HCl. ठीक है, that is what you take. Once you take NaNO2 plus HCl, what will happen is this will create HNO2 plus NaCl will go away from the side. Of course, everyone knows NaCl precipitates very beautifully. Chalo ji. So HNO2 on its own is not a very stable acid. That's why you take NaNO2 and HCl together to create HNO2. Once HNO2 is created, let's look at the structure of HNO2. Right. Now, if you keep an acidic environment around it, if you have the HCl present even right now, yeah, you took a little bit extra HCl, let's say, H positive is present, what can happen is that this oxygen can capture this H positive. Okay? As you know, oxygen can get protonated. This oxygen can capture the H positive. Once it does capture the H positive, what will it become? It will become OH2 positive. This becomes a very good leaving group. Yes. Now, if this leaves away, then what will happen? You will get, of course, you will get H2O. Let's just forget about it. पानी में तो हो ही रहा है reaction. H2O is anyway going to be there. Let's forget about H2O. On the other side, what you get is a very interesting species, N double bond O with a positive charge. ठीक है? This particular species acts as the electrophile over here. This is known as the nitrosonium ion. ठीक है, इसको अपन बोल देंगे nitrosonium ion. This particular positively charged species essentially will now act as your electrophile. I hope you're writing things down along with me. ठीक है, लिखते रहना please. Make your own notes. That will help you revise later a lot better. ठीक है, don't depend on other people's notes and PDFs. Make your own notes. चलो. So once we have the nitrosonium ion, it can act as the electrophile, and a typical electrophilic aromatic substitution reaction will happen. So electrophilic aromatic substitution, once it happens, you know, phenol is an ortho-para directing group. Para is more favored, yeah. So the final major product that you will get in this particular case is going to be phenol that has a nitroso at the bottom. ठीक है, नीचे एक बन जाएगा आपके पास नाइट्रोसो. राइट, कूल, गॉट इट, ऑसम. सो नाउ माय डियर फ्रेंड्स, आई वुड लाइक फॉर यू गाइज टू डू अ लिटिल बिट ऑफ सेल्फ स्टडी. ओके, आफ्टर दिस क्लास इज ओवर, अभी तो काफी टाइम है अपने पास. आफ्टर दिस क्लास इज ओवर, डू अ लिटिल बिट ऑफ सेल्फ स्टडी ऑन लिबरमैन्स नाइट्रोसो रिएक्शन. Okay, it is also known as Lieberman's nitroso test. Essentially, it tests for species that can create a nitroso with HNO2. ठीक है, so HNO2 can create a nitroso with phenol. So Lieberman's nitroso test can actually be used to test phenols in the laboratory. Okay, अगर laboratory में आपको test करना है phenol, so simply make this nitroso that I told you and throw it in an alkaline solution. It will give you a specific color. ठीक है, एक color देगा आपको वो. In a nitroso cases, it is generally a very beautiful blue color. ठीक है, तो Victor Mayer test में भी something like this is done. Anyway, just check it out. ठीक है, make sure you do a little bit of self study on Lieberman's nitroso test. Questions on this have directly come in JEE mains as well at times. Cool. तो एक बार करके देखना. Just try to Google things out on Lieberman's nitroso test. You'll get a better idea. Now the next thing that I'll show you is very interesting. Okay, अगली चीज मैं जो दिखाऊंगा बहुत इंटरेस्टिंग है. What's happening over here? We are doing bromination. ठीक है, we are doing bromination over here. Cool. What is bromination? Essentially, you take phenol in Br2 and H2O. That is what is written over here. In case it is not very visible. So phenol when reacts with Br2 H2O, you know, simple bromination will happen over here. Bromine, it's a species that looks like this. Yeah, you can consider it to be a combination of an electrophile plus a nucleophile. Yeah, and you realize that this particular side can act as the electrophile for the electrophilic aromatic substitution. Simple bromination. Instead of using AlCl3, we are just doing it in water. So what you would expect in this particular reaction is the formation of bromophenol, and given that you don't want steric hindrance to happen, bromine should not approach the ortho position, so it's better that bromine approaches the para position. this is what you expect, isn't it? This is what you expect. But my dear friends, what ends up happening when you brominate phenol in the presence of water, जब पानी present है, when you have water, my dear friends, do you realize that in electrophilic aromatic substitution, in the case of electrophilic aromatic substitution, what is the intermediate? The intermediate will be a carbocation, isn't it? यहाँ ब्रोमीन आके लग जाएगा जब, and when you will also have the hydrogen over there, ठीक है, यहाँ पे OH है अपने पास, cool. Do you realize that there will be a carbocation formation? ये याद है आपको? Do you remember this? Do you remember the carbocation formation? So यहाँ पे bromine भी होगा, hydrogen भी होगा, and then when you remove the hydrogen, this turns into a double bond. So this is the intermediate that you have in electrophilic aromatic substitution. It is essentially a carbocation. Now do you realize that this carbocation is very well stabilized by the presence of a polar protic solvent? Isn't it? Polar protic solvent will stabilize the carbocation. So when you throw this thing in water with bromine, what is possible is multiple bromination, because no matter how many carbocations you generate, it will be stabilized by water. पानी की वजह से वो stabilize हो जाएगा. So over here you can actually create tribromophenol with this reaction. This was a question that we asked on our Telegram group as well. I think yesterday we asked this question. So the thing is, whenever you react phenol with bromine and water, you will get tribromophenol. ठीक है? Tribromophenol is formed, so as it is given over here in the slide as well, it is actually a white crystalline precipitate. ठीक है? This is a white crystalline precipitate. Solidify होके बाहर आ जाएगा. 2,4,6 tribromophenol. Cool? Very interesting. Got it? चलो बढ़िया, very nice. So one of the reasons of formation of this tribromophenol is, एक reason क्या हो गया अपने पास, that there is polar protic solvent, so my carbocation is stabilized. That is one reason. There are more reasons. One more reason is, see, water is, it has a high dielectric constant. So when bromine breaks apart into Br positive and Br negative, these ions are also stabilized by water. Okay, stabilized by water. You know, solvation of these ions will be very beautiful over here, right? समझता है? Got it? Awesome. So these are the reasons. Also, there is one more reason जो आप सोच सकते हो, and that is, what if this phenol reacts with the Br negative? क्या होगा? What will happen if phenol reacts with the Br negative? Do you realize that the Br negative can capture the hydrogen of the phenol? I can say that in water, if bromine negative captures the hydrogen of the phenol, I can get a phenoxide ion kind of a species. Do you realize you will get a phenoxide ion? And this one, okay, this one, I can say that it is more activating in nature. Yeah, this is more activating, isn't it? Because it has a negative charge now. Instead of just the phenol, phenoxide ion is more activating. So these are the reasons that are attributed to the poly substitution in the presence of water. एक बार इसको note कर लो, ठीक है? Just take a little while and note it down. Because of this stabilization provided by water, you will get poly substitution. Great. तो ये तो हो गया. You can pause it and take a screenshot, whatever you want to do. But now as a chemist, you don't always want the highest product possible, isn't it? हमेशा तो नहीं चाहता कि मैं ट्राइब्रोमो बना दूं. I won't want always to make a tribromo species in the laboratory, yeah? So there are ways in which you can generate a monobromo species as well. Can you suggest a way? I'll look at the chat boxes right here. Shakti, thank you so much. Yeah, Shakti was passing a compliment over here. Thank you so much. So, people, can you tell me how do I create a monobromo substituted phenol? What change should I make? Yeah. बताओ क्या सोचते हो आप क्या हो सकता है? DD Matix, very nice. DD Matix is saying you use aprotic solvent. I see more people are enjoying the new board setup. We'll get used to it. थोड़ा सा मैं और research करूँगा कि इसको और अच्छा कैसे बना सकते हैं. Yeah. Vaibhav, thank you so much. So DD Matix is getting a very good idea. Ranjan is saying by halogenation, but in what condition? Savan has already given the answer. Very nice. Deepak has also given the answer, and Aditya has also given the answer. Mamta is saying, I'm very confused about the acetic ester synthesis, which wasn't included in the carboxylic acid revision. Mamta, कर लेंगे धीरे धीरे वो भी. Don't worry. I'll explain it to you in some specific class. Doubt solve करेंगे जब. Don't worry. And anyway, now JEE is very far. Most likely you'll be able to attend my full carboxylic acid classes as well. Anyway, so the idea is that instead of using a polar protic solvent, let's use a polar aprotic solvent. क्यों use करना है water? If I want just one bromination, if I just want mono substitution, then let's use a non-polar solvent. Also, in order to reduce the reactivity, see, reactions happen when you provide them high energy, when you provide them higher temperatures, because every reaction will have some amount of activation energy that it requires. You need a little bit of energy to start the reaction, to initiate the reaction. That is called activation energy. So if you reduce the temperature, the reactivity decreases. अगर टेम्परेचर ही घटा दिया मैंने तो कैसे होगा रिएक्शन? सो टू रिड्यूस द रिएक्टिविटी ऑफ द रिएक्शन, यू रिड्यूस द टेम्परेचर एंड यू यूज अ सॉल्वेंट दैट इज इन फैक्ट नॉन पोलर. तो यहां पे क्या किया अपन ने? वी आर यूजिंग Br2 इन CS2 at 0 degree Celsius. Very nice. Okay, so in this case, my dear friends, you will get a perfect mono substitution. Okay, perfect mono substitution मिलेगा. So your para product will be the major product, of course. ठीक है, this guy will become the major product. You will get a little bit of the ortho product as well. ठीक है, but major product will be your para bromophenol. Make sure you remember this, because questions on this particular concept are asked time and again. Wow. Wait, where is that slide? Yellow. Did you see what just happened? There was an insect that was flying. That insect touched the whiteboard and the slide changed. If the board isn't weird, then the entire universe acts weird. Very nice. कुछ भी चलता है. ये देखो, शुरू हो गया ये. This insect wants to teach you chemistry now. Brilliant. It's raining outside and there are so many lights in this particular room. All the insects are coming in now. कुछ भी चल रहा है यार. चलो बढ़िया है. Yes. So Ranjan is saying at 273 we will get bromine and para and ortho position. Yes, that's why I said that this is the major product. The ortho one will be the minor product. ठीक है, चलो. तो ये हो गया about the substitution of bromine onto phenol. ठीक है. So now that we have started looking at the electrophilic aromatic substitution reactions, let's look at a few more. बताओ. Let's look at a few more cases, right? So my dear friends, over here, what should be the product? I'll make the two products for you. You have to tell me which will be the major product. You are essentially doing nitration of the phenol. So nitration में होगा क्या? That you are getting a phenol, of course, which is nitrated. One of them is going to be para. The other will be the ortho product. You have to tell me which one of these is the more stable product. Para versus ortho, which one is more stable in nature? So let me try to draw that structure in a different manner so that you can understand a little better. ठीक है, मैं बताता हूँ कैसा होगा यहाँ पे. Can you see something can happen over there? Do you see that hydrogen bonding can happen in this particular case? Yes. So my dear friends, in this particular reaction, the ortho product is more stable. Okay, the ortho product is more stable. So one more thing that you should realize in this case is that the ortho product has intramolecular hydrogen bonding. The para product will have intermolecular hydrogen bonding. Is that right? This bonds in its own self. This guy will bond with other species, yeah? This OH can interact with some other nitro, ऊपर कोई और nitro पड़ा होगा of some other phenol. It can interact with that. So you will have intermolecular hydrogen bonding in the para case, intramolecular in the ortho case. So ortho, technically speaking, because of the hydrogen bonding, is more stable. So if you allow the reaction to happen, if you allow more time for the reaction to happen, more stable thing will be formed. Thermodynamic product versus kinetic product. अगर आपको ये याद नहीं है, I'll explain it to you in a little while. ठीक है? So now the thing is, how do we separate these two? How do we separate these two? It's very easy. You can separate these two by distillation. Okay? Simply क्या करना है अपने को? We just want to do some distillation because you realize their melting points, their boiling points will be different. Yeah? Boiling point अलग रहेगा ना इनका. Because this has intramolecular hydrogen bonding, it doesn't bond with other molecules, so this will have less boiling point. This guy, intermolecular hydrogen bonding, bonds with other molecules, so it will have more boiling point. Yeah. So because of this idea, you can easily separate this reaction mixture. कोई फर्क नहीं पड़ता. This is major, doesn't matter. You can anyway separate them. Very nice. Just distillate. Cool. बहुत बढ़िया. ये भी हो गया. Fine. So now one thing that you should notice in this particular reaction is that you used dilute HNO3. है ना जी? You used dilute HNO3. What if I use concentrated HNO3? What if I use concentrated HNO3? There is a lot of HNO3 right now. My dear friends, I am pretty sure you've already predicted. You will get a polysubstituted product. You will get a polysubstituted product. You will get nitro groups on the ortho and the para positions. And this species, do you know the name for this species? इसका नाम तो पता ही होगा if you don't remember. This species is actually called picric acid. Why is it called acidic? Because it is very acidic in nature. ठीक है, काफी ज़्यादा acidic होता है. It's very acidic in nature. I think it's a little more acidic than your normal benzoic acid as well. Just check the exact values online if you want to. But picric acid is very, very, very acidic. In old days, people didn't know that it's a phenol, right? Because in old days, if someone would have discovered picric acid, मान लो किसी ने खोज लिया picric acid, ऐसे धरती से निकाल लिया, yeah, what would that person see? That person would say it's a liquid which is very acidic in nature, isn't it? They didn't know the structure. Only later when they found out it was a phenol. So why is it super acidic? Because of the 3 electron withdrawing groups present, yeah? Withdraw, badhao. Electron withdrawing groups increase the acidity. So picric acid over here increases the acidity of the phenol. I mean the nitro groups increase the acidity of the phenol in picric acid. Too much picric acid. ठीक है? Devesh is saying, do you hit the gym daily? No bro, I haven't been working out since like 3-4 months now. बहुत टाइम से जिम नहीं गया भैया मैं. I wish I was. ठीक है. So now people, there is a little bit of a problem with this particular mechanism, with this particular reaction. There is a slight problem. Okay. A lot of information given on this page. तो होता क्या है that this picric acid is essentially a yellow crystalline solid, but the yield of picric acid obtained is very poor since phenol is highly activated ring which is usually oxidized to quinone and a tarry solution gets formed. See, as I told you earlier, you must be wondering if you've written these in your notes. I showed you that phenol with concentrated HNO3 can actually turn into quinone. या अभी किया था अपन ने. एक सेकेंड. We had just seen that phenol can be oxidized to quinone. So the yield of this trinitrophenol, the yield of this picric acid is very bad when we are using just concentrated HNO3. So there's a better way of creating picric acid in the laboratory if you want. First do sulfonation and then do nitration. ठीक है? That is something that works in the laboratory. Laboratory में, you know things how things work in the laboratory. You think that this reaction will work. You do that reaction. You realize the yield is not very good. It has happened to me too many times in the laboratory. I did a reaction 3 times, and doing a reaction 3 times in the laboratory is not like just mixing 2 things together. You have to purify one substance, you have to purify the other substance. Purification takes 2-3 days because you have to do so many different techniques. You have to do chromatography, you have to separate the chromatography, you have to purify it, you have to evaporate the solvent, etc. Oh. So one reaction in the laboratory, if you are doing it from afresh, if you are doing a new reaction in the laboratory, it takes a lot of time. It takes like a week or 2. एक हफ्ता लग जाता है reaction करने में. After 1 week of the reaction, you're very happy that you got your product, you purified it, you separated it from all the impurities, then you try to see what product it is. You try to do a spectroscopy and then you realize the product is wrong. So something similar happened something similar would have happened if someone tried to make trinitrophenol using concentrated HNO3 just with phenol. So the professor, PhD students or master students do these reactions, and then the professor would have suggested, acha, if you are getting oleum, if you are getting this quinone, then why don't you try it in a different manner? Why don't you sulfonate it first and then convert the sulfonates into nitro? Actually works. Okay, so this is something that works very beautifully in the laboratory. You do sulfonation first and then you nitrate it to get picric acid. Okay? So just remember that whenever you are generating picric acid from phenol, you sulfonate it first and then you create the picric acid. Devesh is saying, sir, is making notes important or just highlighting the important terms in books? See, when you're reading books, you don't need to make notes, but whenever you're attending classes, you need to make notes. ठीक है? बहुत फायदा होगा दोस्त, बहुत फायदा. चलो बढ़िया है. So now, my dear friends, this is a reaction where oleum is reacting with phenol. Okay, concentrated H2SO4 is reacting with phenol. But the thing is, you are doing it in 2 different conditions. You are doing it either at 15 to 20 degrees Celsius or you are doing it at 100 degrees Celsius. Yeah. My dear friends, right now we are already at 8 p.m. So let's keep this class to 1 hour. I'll figure the whiteboard out for the next class. So what is happening over here, sulfonation of phenol at different temperatures, try to find this out. We will discuss. Okay, we will discuss this in the next class for sure. Okay, इसको एक बार खोजने की कोशिश जरूर करना. Try to find out what happens at lower temperature and higher temperature, why it happens. It has to do with the kinetic versus thermodynamic product, and I will tell you this in the next class. Now, when is the next class of phenols? The next class of phenols or the alcohols chapter is going to be on Friday at 7 p.m. ठीक है. Next class will be on Friday at 7 p.m. For all of you people who are studying in 12th class, the schedule for you guys for 2021 full classes is Monday, Wednesday and Friday at 7 p.m. Okay, this is your schedule for all of you 2021 students. Apart from that, if you want to join Vedantu as a paid user, if you want to join Vedantu as a full coaching institute which operates online, it's good. Online is good because we're anyway in the lockdown for I don't know how much time. So yeah, you can join Vedantu as a full student by going to this link. The link is in the description, by the way. You don't need to type anything from what I am writing, just go down to the description, you will see it is vdnt.in/ytpro. Okay, so this is the link that you can go to. The link is in the description box. If you want to join Vedantu as a full long-term paid student, then this is where you can go. So this is something that you should find out. We'll explain this in the next class, and we will also do these two remaining reactions of phenols which are very important: Kolbe synthesis and Reamer-Tiemann reaction. Okay, got it? So now people, what I'll do is I'll just chat with you for 2-3 minutes and then we'll call it a day. मैं थोड़ा और सेट करने की कोशिश करता हूँ इसको फॉर द नेक्स्ट क्लास, देखते हैं कैसा होता है. They were just saying if you are studying subjects like physics and chemistry by books and making our own notes. Making notes from books is a very bad idea any day because books are already written. Making notes from classes is a good idea because classes give you a lot of information in a decent amount of time. But you want to revise whatever I've taught in 1 hour in just 10 minutes later on. है ना? So that's why this is important. Books में तो यार सब कुछ पहले ही लिखा हुआ है ना. Now since you are attending these classes, make notes from the classes. It'll help better. Okay. But yeah, Ashutosh is saying, which is your favorite bike? I like all sorts of bikes, man. I have a Ducati Diavel, so I like that. Mamta is saying, is next class based on the advanced problems? Mamta, if you're talking about the 8:30 class, it's the NTA question solving. ठीक है? काफी जोर लगा के व्हाइट बोर्ड चल तो पड़ता है, क्वालिटी इतनी अच्छी नहीं आती इसकी. It's not a very beautiful board. Should have done something better with the panel. It's actually meant for, you know, real life classroom teaching, so the exposure values and the brightness values of the board don't matter. Over here, if I decrease the exposure of the camera, it will focus on the board, but I will look like something weird. दिखूंगा ही नहीं मैं. हाँ, so Shivam is asking, sir, this change in syllabus of CBSE, is there any effect on JEE, yes or no? See, it affects people who are going to give the examination in 2021. So people who are giving the examination in 2021, their syllabus is reduced by a bit, but understand that any important bit is not removed. Very secondary or tertiary things are removed, like Van 't Hoff factor, I read it is removed. Physical properties of methanol and ethanol are removed. Uses of ethanol and methanol are removed. The places from which questions were rarely asked, those are removed. ठीक है? So practically speaking, it's just a 10% decrease in syllabus. You won't have to deal with the Arrhenius equation. You won't have to deal with collision theory. You won't have to deal with the Van 't Hoff factor. So there are some things that have been removed. Yeah, but again, won't really affect the way in which we study or answer the questions. थोड़ा सा शायद easy हो जाएगा सबके लिए, but that syllabus change is applicable only for the 2021 students. Okay, so please keep that in mind. ठीक है? Abhishek is saying, sir, what is this target JEE and NEET which Vedantu is launching on the 12th of July? So Abhishek, it's basically a full revision course for people who are moving from 10th to 11th and people who are moving from 11th to 12th. So let's say you've just moved to 12th class and you don't remember a lot of things from 11th class. So it's like a marathon of revision classes that will help you revise 11th class. Similarly, for people who are moving to 11th, it's like a foundation course marathon. So all details of this course I will give you tomorrow. कल मैं एक वीडियो निकालने वाला हूँ इस पे. I think at 7 PM I'll take a video on this target JEE and NEET marathon. ठीक है? IIT aspirant, there's a person in the chat box called IIT aspirant. He's saying, can we crack JEE in 1 year? Definitely you can. पढ़ाई करो अच्छे से, you can definitely crack it यार. Obviously you can. Pavel Ahmed is saying, sir, paid or YouTube में क्या difference है? What's the difference between the paid and YouTube classes? See, on YouTube classes, if you see, I just take classes and I tell you, okay, bye. I don't tell you that you have to attend the classes. It's not compulsory for you. If you want to attend, you can attend. Yeah. The difference between the paid course and this is, the paid course will have live classes, of course, that is same. You will have the recordings of the live class, that's also the same. But if you don't attend 3 classes, they will call your parents and they'll tell your parents, "Bachcha padhai nahi kar raha." Another thing is that you will get all sorts of assignments, study materials, notes, etc. So people get confused on which book to follow, which book to not follow. You don't have to worry about that when you join the full paid course. You will be given a proper study material that has all the questions, etc. already. You will get regular tests as well. Tests will be discussed in the classes. So it's like joining a coaching institute, but online. That's the difference mainly, that you will be held accountable and you will be given all sorts of material and tests along with the classes as well. ये फर्क है. D square, what's up man? चलो बढ़िया. Raghunath is saying, please explain physical properties, sir. Bro, the properties that are physical are called physical properties. If you are asking a question, I suggest you to be a little more elaborate and tell me what you actually mean. Physical property of what, bro? Physical property of this marker. It is gray in color. It is solid. It is able to write. If I throw it, it will break. Physical properties of what? Okay, so there's a person in the chat box, random bro. Do you understand that this channel is Vedantu's channel? Do I need to say anything more? Come on, man. Shoaib is saying last class homework. बता दिया भैया, in the middle of the class I have told you that. Aman is saying please teach the removed topics as well. I think I will do that because people might watch those classes earlier and later as well. Chalo, anyway people, thank you so much for joining in. I will take your leave right now. This is all for today's class. The next class of alcohols chapter is going to be on Friday at 7 p.m. Now at 8:30 we are going to solve another another JEE NTA mock test number 36. So for those of you who want to attend that class, I will see you at 8:30. Until then, thank you so much. Bye bye. Take care. See you soon.